Hello and welcome to this Solidity 2024 course. In this video, we will learn all about functions and the concept of storage variables. Remember, this is part of a much bigger Solidity course, which I will include in the link below. Just like last time, we will work through problems and I will explain to you what is happening and why. Any questions you have, please comment them down below and I'll get back to you as soon as I can. Now, let's begin. Functions allow us to execute custom logic within our smart contracts, be it sending ether, receiving ether. Now, ether is just another name for the native currency of Ethereum, so this changes based on whatever blockchain that you're on. I mentioned earlier that public variables have an innate getter function, so we can call them. And in this example, we're using that innate getter function by just declaring x again, and inside of this change x function, we are reassigning it to the value of 5 from 3. So this is how you update state variables or storage variables in Solidity. Task 1 of Solidity functions. Constructors are executed on deployment of the smart contract, and they are only executed one time. Let's scroll down to the task at hand. Create a constructor which will take a uint as an argument. Okay, so constructor takes a uint, and we can call it whatever we want. The example says to take this uint and store it in a variable called x. So I'm going to call this x as well, and we're going to say x equals x, uint public x. So now if we head over to our details tab, it mentions something called variable shadowing. Because we have given it the same name, Solidity will catch that and warn us about this. Click on your compiler here, and it will say this declaration shadows an existing declaration. So this is a warning to let you know that this will cause problems. Easy fix for this is to give an underscore to constructor parameters so that they are not the same variable name. Underscore x is different from x. Let's run the test, command enter. In the second task, we will be exposed to external functions for the first time. These are functions that are called by an EOA or externally owned account, which is a fancy term for a cryptocurrency wallet. In our case, we'll just say MetaMask. So let's create a function here. So create an external function, increment, and then parentheses, external, curly braces, that will add 1 to the state variable x. So it'll be x plus equals 1. This is a syntax used to say x equals x plus 1. We can shorten this or concatenate this into this syntax here, so it's just cleaner, and most developers or all developers can understand this. Okay, so let's press command enter. Perfect. Next stage. Now we're going to learn how to return values from functions. So below this, I'm going to say, let's scroll down, create an external view function add, which takes a uint and returns a sum. So function add, it takes a uint parameter, let's call it a, external view. View just means that this function does not interact with any state, so it does not touch the state variable at all. Real quick, I do not need to add in 256 here because it's assumed that without that, it's using uint 256 under the hood anyway. But if you want to be specific, you can say uint 256, but it's just cleaner again just to say uint, as the compiler already knows what you mean, which is the uint 256 data type. Okay, so now we need to add these two together. So it's going to return a plus x. Simple. Perfect. Next stage. In the fourth challenge, you're being introduced to the concept of console logging using Forge standard library, which is a Foundry feature, as I mentioned earlier. So all you have to do is console.log secret message, and let's run this. It's going to fail the test because we haven't actually returned anything. Now the console log is saying return the value 794 to win. This came from the call data secret message, which means that it was passed in from an external call to this function Don't worry about what that means. We'll elaborate on this, I believe, in the next section or the one after that. So now we've console logged the value, we know what it is. Just simply below this, return 794, run it again, next stage. Pure functions do not read or write from state. So in the previous one, you saw it read from state, but this one does not. So let's scroll down to the task. Create an external function. There's a function called double. It's going to be external pure, and it's going to return a uint value. Oh, it's going to take a uint parameter as well. Let's call it a. Let's say return a times 2. So this is the syntax for multiplication in Solidity and most programming languages. Function overloading is a feature that is available in most programming languages as well. In this example, we have a function called add, which has 2 parameters, and below that, another function with the same name, but it takes in 3 parameters. Each function have their own logic in them. So the reason why we can do this is because this will generate one function signature, and this second one will generate a different function signature, so they do not overlap when you try to call them. Let's scroll down to the task, create another pure function called double, which takes 2 uint parameters. So function double uint a and uint b. Double both of the arguments and return both of them in the same order that were passed into the function. So we actually need to use something called tuples here. So I need to change this to uint, and then in here we say return a times 2 and b times 2. This is a syntax to return multiple values in Solidity. Command enter. Whoops, I forgot to label this external. Now let's run it. Perfect. Thank you for watching. Any questions that you have, please comment below and I'll get back to you as soon as I can. In the next video, we will focus on sending ether using functions, so we will elaborate upon what we have just learned. Thank you for watching and I'll see you soon.